In an experiment, we also have an experimental variable, sometimes called a treatment variable or an independent variable. This is the variable that you change to see how it affects the target variable. In the new product introduction experiment that we are setting up, the experimental variable is the sale of the new candy. The other variables or data that we have about the units are called control variables. These are analogous to predictor variables in modeling. They are the variables that are most influential on the outcome of the target variable. In our experiment, there could be other information about the stores that are available to us as an analyst. The other variables or data that we have about each store, such as sales, customers, demographics, or location, would be known as control variables. Control variables are treated a little differently than predictor variables. They're not going to be used to build an equation to make a prediction on a future value. We already know we don't have enough information to do that. Instead, control variables are used to make sure that the treatment units and control units are as similar to each other as possible. This allows for the comparison of the target variable to be as accurate as possible. For instance, in our experiment, we want to know the effect of adding a new product to the set of products that our brand sells at a store. We look at the effect of adding the product to the whole set of products that the brand has, because if people buy the new product instead of the one they would have bought anyway, then the new product could have more sales but cause losses in other products. In order to compare a store that is going to sell the new product to one that is not, we need to make sure they are as similar as possible. For example, we want stores of similar sales levels, geographies, customer demographics, etc. This is super important because we want to measure the impact of the product launch independent of other factors.